This is Algebra 2, Lesson 2-1, direct variation. Direct variation occurs when two variable quantities have a constant ratio. The equation is y equals kx, or y over x equals k, where k cannot equal 0. The k is your constant of variation. That's the constant ratio in a direct variation. For example, if I had the equation y equals 3x, my constant of variation would be 3, which means no matter what I put in for x, y will be 3 times whatever x is, because that's the direct variation. Now, in order to be able to work with direct variation, you have to be able to identify it. One of the first ways to identify it is by identifying it from a table. So, if I was given a table for each function, we're going to determine whether y varies directly with x. If it does, we have to figure out what the constant of variation is and what the function rule is. The easiest way to figure out if something is a direct variation is to remember the equation for variation is y equals k times x, which means that k will equal y divided by x. So all we have to do is look at a table and see if the y divided by x is the same ratio for every problem. If it is, then it's a direct variation. If it is not, then it's not a direct variation. For example, here, if I look at y over x, I'm going to have 0.5 over 1, which is basically 1/2. Okay? Then I'm going to have 1 over 2, which is 1/2. And then I have 1.5 over 3, which would be 15 over 30, which would be 1/2. So, since y divided by x happens to be the same ratio all the way through this table, when I took my y value of 0.5 and I divided by x, which was 1, or if I took 1.5 and divided it by 3, I got the same exact ratio every time. This is a direct variation equation, so we can say yes, it's a direct variation equation. Okay? The constant of variation is 1/2, and therefore the equation of variation is y equals 1/2 x, or y equals 0.5x. It really doesn't matter if you put it as a fraction or a decimal. Let's look at the second one. If I do y divided by x, here we have 4 over 1. Here I have 8 over 2, which equals 4 over 1. And here I have 11 over 3, which equals 11 over 3. So the first two were on track to be a direct variation, but by the third point, it was no longer a direct variation. So it's not a direct variation. Because y over x is not constant. Let's look at the third one here. Y divided by x, 10 over 1, which equals 10. I have 22 over 2, which equals 11. And then 33 over 3, which also equals 11. So again, it's not a direct variation. So you can look at a table and determine by the constant of variation whether or not it is a direct variation. Let's look at some equations. Can we determine from an equation whether or not something is a direct variation? Okay. So let's look at it. The first thing we have to do is we have to write it in direct variation form, which is y equals kx. So we have to solve it for y. Okay, so in this particular case, I'm going to subtract 2. So I'm going to get y equals x minus 4. This is not a direct variation because we have this extra piece at the end. A direct variation does not have anything added or subtracted to it, but right here we have the negative 4 that is subtracted from x. You can have things multiplied by x, but you cannot have things subtracted or added to x, so this is not a direct variation. Okay. If we look at this one, y divided by 6 equals x. First thing we have to do is solve this for y, so we multiply both sides by 6. So I will get y equals 6x, and yes, it is a direct variation, because there's nothing added or subtracted, it's only multiplied. So yes, it's a direct variation. My constant of variation is 6, and that's all we needed for this particular problem. Okay? Direct variation, constant of variation is 6. So if you solve an equation, and it's y equals something times x, and there's nothing else, then it's a direct variation. If you solve an equation and it's y equals something times x plus or minus, then it is not a direct variation. In a direct variation of the y over x is the same for all pairs of data, because we said that. The y over x has to be constant. That's what gives it the definition of a direct variation. So, if I had a proportion, y1 over x1, that should equal y2 over x2. So that's true for all the ordered pairs, provided that either x1 or x2 happens to be 0, because division by 0 is undefined. So you can use that idea of that proportion to solve direct variation. So suppose y varies directly with x, and y is negative 4 when x is 25. What is x when y is 10? So if I use that proportion, y1 over x1 equals y2 over x2, and remember that's the proportion, y1 over x1 equals y2 over x2. If we use this proportion, we can solve this direct variation. So suppose y varies directly with x. Y is negative 4 when x is 25. What is x when y is 10? So y is 10. What is x? Make sure you put the x's and the y's in the right spots. Even notice this was written, what is x? Well, x still has to go on the bottom because y goes on the top. So now I just cross multiply to solve this proportion. So I get negative 4x equals 250. Divide by negative 4. And x will equal negative 62.5. And that's what x equals when y is 10. Simple enough. Let's look at another one. If y varies directly with x, y is 15 when x is 3, so y is 15 when x is 3. What is y when x is 12? So y over x equals y over x. I set them up correctly. Cross multiply, 3dy equals 12 times 15, which is 180. Divide by 3, y equals 60. Alright, you can also use direct variations to solve problems. You just have to make sure you set up the proportion correctly. It says the cost of buying fancy nuts varies directly with the weight. Okay, it's important to know, so I'm going to write that down. Cost varies with weight. That's going to help me remember which goes where. Okay. It says if an 8.5 kilogram bag of nuts costs $47.50, so my cost $47.60 over my weight 8.5 kilograms. How much do 20 kilograms cost? Well, cost is here, kilograms is down here. So it should be 47.6 over 8.5 equals C over 20. If I cross multiply, 8.5C is going to equal 950. Divide by 8.5. C will equal 111.76. So $111.76. And we should write this in a complete sentence. So it will cost $111.76 for 20 kilograms of nuts. Let's look at the second question here. Screen. Calories varies directly with the mass of cheese. In other words, the more cheese you eat, obviously the more calories you consume. Okay, so calories varies directly to mass. Okay. 50 grams of cheese has 200 calories, so 200 calories goes on top, 50 grams goes on the bottom. Those grams is on the bottom, mass is on the bottom, and calories are on the top. How many calories, that would be X, is in 70 grams of cheese, that would be 70 down here. So we now have 50x equals 14,000. So we cross multiply, divide by 50, and x equals 280. So there will be 280 calories in 70 grams of cheese. last but not least, we're going to graph direct variation equations, which are really simple to graph. The thing you must recognize is all direct variation equations must go through the origin. If they do not go through the origin, they're not direct variation equations. So we have y equals x over 5. Now there's many different ways you can do this. Some of you remember how to graph using slope-intercept. Some of you want to make a table of values. It really doesn't matter. Basically, y equals x over 5 is the same thing as saying y equals 1/5 x. So if I did a little table, did a little x and y table, I could use negative 5, 0, and 5. If x is negative 5, 1/5 times negative 5 is negative 1. If x is 0, y is 0. If x is 5, y equals 1. So then I can just graph those points really quickly. Negative 5, 1, 2, 3, 4, 5, 1, 0, 0, 5, 1. I can draw a line here really quickly. Let's go with the line. Let's see, I need to have, that's the bigger one. Let's do it in green. Let's see if I can make this smaller. And we just slide it. There we go. And there's my direct variation equation. And of course, we should always label it. Always do the label your direct variation equations. This would be y equals x. And label your x and y axis as well. Okay. Letter B here, y equals negative 4x. I'm going to use slope-intercept. Remember, my slope is the number that comes in front of x, which is negative 4 over 1. My y-intercept here is 0. So I'm going to drop the point here to 0. I'm going to go down 4. 1, 2, 3, 4 to the right 1. And I can continue doing down 4 to the right 1 if I wanted to. I'm going to draw my lines again. So let's do a line here. Make sure that everything is the same. Yep. Color. Let's make this one blue. And just line, and I missed massively. So now I can move my line. So that it fits where it's supposed to go. You would use a ruler. I can't use a ruler on the smartboard, but I can count really close to putting it where it needs to be. And there's my line, and of course I should label it y equals negative 4x. Remember, a graph of a direct variation must go through the origin. And that's all there is to direct variation.